Hello, Math 120, and this is Professor Gonzalez, and I'd like to do some problems from homework 2.4. So we're doing more work with functions, and this first question is just making sure you remember slope-intercept form, and that is, it says, for the graph of the linear function f of x equals mx plus b, m is the slope. So we're going to fill in slope here. Whoops. M is the slope. M is the slope. And it says, and 0 comma b is the y-intercept. All right, next question, kind of on the same line. It's asking for the linear function f of g equals negative 4x plus 8. The slope is, and the slope is always this coefficient in front of the x to the first power, negative 4. So the slope is negative 4. It says to type your answer as an integer or fraction. Negative 4 is fine. When I actually step it out, I like to write it as a fraction, negative 4 over 1. But just writing the answer down is fine that way. And then the y-intercept, of course, is this value right here. You have to take the sign with it, and that's going to be 8 is the y-intercept. And so we go down here and you say the y-intercept. And always be careful when you're answering these questions. It says type an ordered pair. Type an ordered pair, there it is. So you have to write it as an ordered pair. That's 0 comma 8. Okay, next question says, please graph the function 4x minus 5. Well, we always start with our y-intercept. That's a starting point for us. The y-intercept, of course, if we write it as a ordered pair, 0 comma negative 5, and that is down here, 0 comma negative 5. Now we take a look at our slope, and a slope, of course, is the coefficient in front of that x. 4 over 1, that literally means go up 4 and right 1. So from that starting point, go up 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1. And those are, you only need really 2 points, but there are plenty of points there to make our line. And I'm just going to snap a line that way too. Come on, snap. It's not snapping. Try that again. Okay. There's our line, our function f of x equals 4x minus 5. Let's move on to the next graph, and it's another linear graph. So this section is all about linear graphs, linear functions rather, and then also some word problems that show linear function models. Okay, once again, we always like to start with our y-intercept. Y-intercept is 0 comma positive 1 in this case. 0 comma positive 1, and then the slope of this guy is negative 5. I like to write it as a fraction. Negative 5 means go down 5 and right 1. Negative 5 means go down 5. 1. I'm going to zoom in. 1, 2, 3, 4, 5. It's 5 because we started here, not at the origin, right? We started at that point. So it was 1, 2, 3, 4, 5, and then right 1. This gives us this negative slope that I can make my line with. I think I'm going to zoom in still. And there is the line. There's your function f of x equals negative 5x plus 1. Moving on to the next, our y-intercept once again is that b value. So we start at positive 3. And it says that the slope is a fraction, which we always like to write the slope as a fraction anyhow. That means go up 1, right 7. Starting right here, we go up 1 and right 1, 2, 3, 4, 5, 6, 7. Up 1, right 1, 2, 3, 4, 5, 6, 7. Let's go ahead and make our line. And there is our linear function, f of x equals 1/7 x plus 3. Moving right along, this is a function, and it's f of x equals 2. Remember I was harping on you guys about that? Y equals 2 is going to make a horizontal line. And y and f of x are interchangeable in this case, so this makes a horizontal line. Of course, it has a slope of 0, but more importantly, it makes a horizontal line at 2. So there's our horizontal line at 2. That is f of x equals 2. Now remember, this is a function, and you could do the vertical line test on it. You know, if you draw a function anywhere, draw a vertical line anywhere on that graph, and it will only cross in one location, so it is a function. The only types of lines that are not functions are vertical lines, because they fail all over, everywhere. They fail along that vertical line. Okay, let's move on to the next problem. Roberta's monthly payment for her new car are $214 per month. She estimates that maintenance and gas costs her 13 cents or $0.13 or $0.13 per mile. So this is going to be a nice linear model, and something you probably want to remember, I got a little space to work up here, is this idea, right? Y equals mx plus b. And since we're talking about functions, we should replace y with f of x. Okay, now we just did a bunch of these, and we said that we started with the y-intercept. We said this value is the y-intercept. And we said this value is the slope. So that's still true. But when we go to the context of a word problem, this b value, it's still the y-intercept when you're graphing it. But it's in the word problem, it's usually something like the starting amount. Or it might be a one-time fee or one-time starting fee or one-time monthly fee. Something like that. That's usually what that b is, the y-intercept. And in the context of the problem, the slope, or the m, is usually cost. It's usually cost per x, whatever those x's are, cost per x, where x is whatever. X is whatever the problem is talking about. Okay, well, let's see if we can identify those pieces. So Roberta's monthly payment for her new car, R sounds funny, but R, $214 per month. She estimates that maintenance and gas cost her 13 cents per mile. Write a linear function that expresses the monthly cost C of operating the car as a function of miles driven. So the way they're saying this is, I don't know, maybe a little bit, maybe I worded it a little bit differently, like in this area. But basically, Roberta has a monthly cost for her car that she has to pay. And that's what we're trying to figure out. Write a linear expression that expresses the monthly cost for her car. So we're going to use, let me use this. They want us to use function notation. So let's go ahead and do that. And I'm going to say C And let's see if they're defining any of these variables here. Yeah. Okay, look at, they have it right there for us. So we're going to call this C of X. Now C of X is the total monthly cost of this car, okay? Now they're telling us that no matter what happens, she has to pay that fee right there, $214. That is a starting cost or a one-time or a flat fee per month. $214 is what it cost for that car. It's not the total cost. $214, it's just sitting in the garage for a whole month. It's still going to cost you $214. $214, if you drive it all day long, that flat fee is still $214. But if you drive it every day, now we've got to put in the cost per mile, right? It costs you per mile. There's gas, there's maintenance, and all that stuff. So the cost per mile is going to be your slope, actually. But let's take a look at that. It costs her 13 cents per mile. And by the way, they told us right here, let me change colors. They said, okay, C is the operating cost. C is the monthly operating cost. And what is X? X is the miles driven. X is the miles driven. So that's why this gets multiplied by X. Let's see if we can make sense of this. So her monthly cost for this car is $214. She has to pay no matter what. And then she has to pay 13 cents for every mile driven, right? So if she had that car, sat in the garage, and never drove it, it'd be $214 because 0 miles times 13 cents is 0. However, what if she had that car and in 1 month she drove it, let's say 100 miles? Well, then it would be $214 flat fee, and then you have to say 13 cents times 100, which gives you 13, and so then it would be 13 plus 214. Total that up, and that's the cost for the month. So this is our cost function per month for driving the car. Okay, so let's go ahead and put that in. I think we figured it out. C of X equals 0.13 times X plus 214. What is the domain of this linear function? Okay, so whenever they're asking about domain remembers all the X values. Now, when they're asking about the domain in the context of a problem, right? In the context of a problem, well, you got to be a little more careful because the domain is talking about the X values, right? And the X values, let's write down here. We need to know context. And the X values in the context of the problem, the X values are miles driven right here. So our domain has to represent that. What's the least amount of miles you can drive? That's part of your domain, right? 0. You can't drive negative miles. So the domain, talking about the X values driven, would be 0 is the smallest. You can actually drive a car with 0 miles. But the upper end of that is something we don't know. On some of these word problems, there actually is an upper end. But in this case, we don't know how many miles they're going to drive. So in that case, we're just going to keep it open. And it goes towards infinity. We don't know how many miles. They can drive many miles. They can drive less miles. You can say, well, I can drive, 50 miles every hour. So I'll just say that for, 24 hours a day for 31 or 30 days in a month. But, what if you drove the car, a faster car, 150 miles per hour every day? So it's just too ridiculous. So anyways, the domain in the context of the problem is going to be 0 miles driven to going towards infinity. What is the monthly cost of driving 286 miles? Now remember, 286, what you want to know, is that the X value or are those the, or is that the cost of driving the got to get a little glass of water. And remember, it's, usually a good idea, excuse me, they already did this for us, but they basically said, and it's a good idea with word problems, is to define let x equal miles driven. And there really wasn't a place for that in my math lab. But that helps us to realize that when it says, what is the monthly cost driven when you drive when x equals 286 miles? So what that means is in the context, let me kind of get this, give us some space. In the context of our problem, we have this nice little formula here that says the monthly cost of driving this car when I drive 286, x is 286, and I just copy the rest of my formula, equals 13 cents per mile, which we went 286 miles, plus that flat fee of $214. And so then you multiply, and you get $37.18 plus 214, and add those together, and we get $251.18. The proper way to write that would be C of 286 equals, so if I drive 286 miles, it's going to cost me $251.18. They already have a units of dollars there, so I'll just let that go. And next problem, how many miles can Roberta drive each month if she can afford the monthly cost? So let's see, do I have space to work here? This is getting really tight. Maybe if I zoom in. So the question is, the monthly cost, is that x or is that c of x? Well, c of x, remember c of x is actually the, let me go to a tinier font or pencil size. C of x actually is the cost, the monthly cost. And so when they say how many miles can Roberta drive if she can afford, this is a cost, right? So that means that C of x equals $245.59. That's the cost. So what we want to do is we want to get our formula, which was C of x equals 13 cents per mile driven plus that flat fee of 214. Now we know that what is the cost? What can she spend? She can spend, right? She can afford, there it is right there. She can afford a monthly cost of, so that means we're going to replace this right here, the C of x, with $245.59. And now we have an equation with one variable, and it's just a linear equation. Solve it. So what do? We just come along here and we subtract. We want to isolate the x, so subtract 214 on both sides. All right, subtract 214 on both sides, and when we subtract 214 on both sides, we get $31.59, and that equals 0.13x. Solve for x by dividing by 0.13 on both sides of the equation, 0.13. And when we do that, we get our answer, x equals 243. Remember, x is the miles driven, so it's 243 miles. Dang, that's getting a little sloppy. 243 miles driven. So if you drive 243 miles, it will cost you that amount of $245.59, which is what she can afford. So that tells her, okay, you can drive 243 miles with that budget. Okay, let's see, make that pen a little bigger. And now we want to, oh, I take that back. Those graphs are tiny. I better make the pencil drawing size smaller. Graph the linear function. Choose the proper graph. Okay, well, you got some clues here to work with. First of all, we do know, and I'm going to make that green real quick so I could highlight, you see what I'm doing. We do know that the y-intercept is 214. So when we're looking at this particular problem, that y-intercept has to be 214. So let's take a look at some of these problems right here. Okay, so let's look at the scale here. Let's look at this scale. Let's see, so this is, let me zoom in, it's really tiny. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 to get to 500, so it must be going by 50s, I'm thinking, right? So 50, 100, 50, 200, 50, 300, 50, 400, 5,500. Okay, so what is this approximate? It looks like it's a little more than 100. So this y-intercept, I was doing my y-intercepts in green, so this y-intercept's probably like 105 or something like that. I don't know. But it's definitely not where it needs to be because it's supposed to be, right, 214. We're supposed to have a y-intercept of approximately 214. So this one is definitely not going to work. And you can see because it's way below that mark. Now in this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this must be going by hundreds. So that's 100, 200. And I can only zoom in so close, but 200, that looks approximately at 214. So I'm going to say that y-intercept is okay. And then I got to check the slope. This one is scale of 500, so 50, 100, 150, 200. This one really looks good. Like this is a y-intercept of 214. So that looks very possible. And then the last one, yeah, that looks like 214 as well. That y-intercept right there is. So these two look really good. This one over here, it's a little bit hard to tell because it's so steep. But I mean, I gotta think about that one too. But it looks like it's maybe a little too low. But this graph it's really hard to tell. So now it's down to the slope. Now you could look at the slope, and sometimes looking at the slope on these graphs, let me just talk about that, how to think about it. Remember our slope here is 0.13. And if you write 0.13 as a fraction, that's going to be, so 0.13 as a fraction, that's 13 hundredths. So that's 13 out of 100. That literally means going up 13 and right 100. That is not a very steep slope. Well, first of all, it is a positive slope, and this is negative. So it can't be that one. Now we're down to those two. And you could actually also see that this slope looks like it's going up 1, 2, 3, and over 1. Well, that's 3 over 1. And if I tried to, if I tried to get a common denominator so I can compare those two slopes, if I add the bottom, I have 100 to the bottom and I add 100 to the top, that's up 300, right 100. That is way more steep than what we're talking about. So I'm pretty much by the process of elimination down to saying, I think, no, I really do know my answer is going to be C. You could also pick a point and graph it. And because we do have, oops, undo, how'd that happen? We also have many points, at least 2 points that we can graph. I'm going to show that technique on the next one, I believe. That's what I'm going to do. So let me make this a little bit smaller. Okay, so we got that taken care of. Let's take a look at the next one. And the next one says, find the zeros of the linear function. So if you remember, finding a zero, let me take some notes here. Zeros of a linear function, or really any function, zeros of any function is when f of x equals 0. And then what do you do? Then find what y is. This is, pencil's too tiny now because I zoomed in. Okay. So finding a zero of a function, essentially, oops, that doesn't look right. Zero of a linear function is when f of x equals 0. And remember, that's also, you could also say when y equals 0, then find x. Where'd that come from? Then find x, not y. Find x, ... So what you can do is you can set this f of x, which is the y, equal to 0, and then solve it. So I used about too much space here. Let me see. Guess I'll squeeze it in over here. And what's the equation? It is 0 equals negative, negative 4/5 x plus 8. And I'm trying to get spacing here because I'm going to be out of space when I have to show my work here. This is 4/5. Let me try again. This is 4/5. Okay, so what do we do when we solve? We're going to have to subtract 8 on both sides. Subtract 8 on both sides, right? So, so now we have a negative 8 on the left, and that equals negative 4/5 x. Okay, the easiest way to turn a fraction into a 1, you could divide it by negative 4/5, or you can multiply by the LCD, and the LCD is negative, I'm sorry, not the LCD, the reciprocal is negative 5/4. So if I multiply the right side by negative 5/4 and also the left side by negative 5/4, and if it is more comfortable, put that negative 8/1 so you know that's up top in the numerator. Now these two guys, when multiplied, oh man, it switched over on me. When these two guys are multiplied, they're going to make a 1. So now we have 1x, just what we want. And over here we multiply. We could also reduce if you want, but you could also just multiply the numerator, which is a negative 8 times negative 5, which gives you what, 40. And on the bottom is divided by 4. This answer, 40 divided by 4, is 10. So on this particular problem, when they asked for the 0 of the function, it is 10. Let's look at the next one, and they're trying to get us to understand function notation. We did this in the last homework sets, 2.3, I think we did some of these, but this is important. We're going to do more of them right now. So they say solve f of x equals 1. What does this mean? When it says f of x equals 1, basically what it means, keep on having to change around, basically what it means is y equals 1, then question, what's x? What x goes with that? So what you want to do, and so I have to zoom in, I keep on having to change my sizings of this lead weight, or whatever you want to call it, digital pencil, but when y is 1, well, look on the graph, where's y equal to 1? Oh, there it is right there. What is its x partner? And what's its ordered pair is 6, 1. So solve f of x equals 1. Well, x is 6, right? 6, 1. Same thing here. Use another color. This f of x equals negative 4 is basically saying when y equals negative 4, what is its x partner? Let's see. When y equals negative 4, y is negative 4 down here, so its x partner is negative 4. So x must be negative 4, which matches up with y equals negative 4. Okay, what does the next one say? Next one says f of 8. Well, f of 8, when you have the 8 in that position, that's saying x equals 8. What y value goes with it? Now, f of 8 equals, and that would be the y value, but but this is how we think of functions. F of 8 equals the y value where x is 8. So let's go find out where x is 8 and find its partner that goes with it. So x equals 8 happens to be right there. So what is the y value that goes with it? 2. So f of 8 equals 2. What are the intercepts of the function y equals f of x? Well, the intercepts of the function, we've got x-intercept, which is right here, and we have y-intercept, which is right there. This one's easy to just forget and do one of the intercepts, but it said plural, right? Intercepts right there. So we have to get x and y. So that means we're going to have to put down 0, -2 is the y-intercept. And it says use commas to separate your answers. And it also says right order pairs, right? So it's always good to look at that. Otherwise we get it wrong and it's frustrating. 0, -2, and then 4, 0. Okay, what's next? Write the equation of the function whose graph is given in the form of f of x equals mx plus b. So we're going to need to write this equation. Well, we have a couple things. We do have the y-intercept right here. So that is the b value, right? Let's write this up. F of x equals mx plus b. Well, we now have our b value because it's the y-intercept. So we have the b value. I'm going to make that thicker again. So we now have the b value. So we have -2. If I'm just kind of writing down what I have, okay, I've got the x right there. And I've got f of x. So I need to find the slope. I need the slope, and that'll go right there. Well, the slope is, I can just go from one point to the next, and that'll tell me the slope. Tell me the rise. How far do I go up? 1, 2. So the slope is up 2, and right 1, 2, 3, 4. Up 2 and right 4. 2/4. Well, we like to reduce our fractions, so how about that reduces down to a half? And you might say, well, wait, 2/4 is stepping different than stepping in a half, but you will see that, let me see if I could highlight this. This first one we stepped up 2 and over 4, and it put us on the line. But what if we just step up 1 and over 2? It actually still puts us on that same line. It's a smaller step, but it's proportional, so it continues to put us on that same line. So what is the equation of that line? Well, we just figured it out. F of x equals 1/2 x minus 2. And that was number 9. How much more do we have? We just have one more problem. Okay. Wait a minute. Did we get everything on that? I feel like we're missing something. That's 9. No, there's an empty page on the bottom half. Okay, so now we've got number 10, back to a word problem. Now these are linear models. A phone company, so what I want you to do when you're thinking through these linear models is I want you to think about a flat fee or a starting number. That's your y-intercept, your b value. And then I want you to think about the variable that changes the cost or whatever. And that's going to be your rate or miles per, cost per mile or something like that. That changes depending on how many of whatever's going on is happening. Let's get into this. So, a phone company has a long distance phone plan that charges a monthly fee of $5.96. Okay, so no matter if you it doesn't matter if you call or not, there's a monthly fee. And I'm going to do this in green because it is the y-intercept, right? $5.96. No matter what happens, you have to pay $5.96. That is your flat fee. Then if I read on, it says plus, I'm going to do this in red, plus 6 cents per minute. Now, they tell us they define the variables for us a little bit here. They're telling us minutes, M is going to be representing minutes, and B of M is the monthly bill. So that's how they want us to write our function. B of M is your monthly bill, and M is the minutes used. So M is my variable, minutes used, and the slope is just going to be this rate of 6 cents per minutes used. So we can kind of get a feeling for how much this is. Phone companies has a long distance phone plan that charges a monthly fee. So this is find the linear function that expresses the monthly bill. So let's kind of go through it here. She gets this plan and she doesn't make any calls. So that would be how many minutes? 0 minutes. 0 times 0.06 is 0. So even if she doesn't make a call, she still has to pay the flat fee of $5.96. Another situation, kind of doing what I did on the last model. But let's say she talks on the phone for 100 minutes. Okay, well, she still has to pay the $5.96 of flat fee, but now it's 100 times 0.06, which is 6. So now her monthly bill would be $11.96. So I just wanted to kind of show you how this formula works by doing a couple of problems, and that was not required in the questioning. But what was required in the questioning is they want us to find the formula, right? So the formula is, or the linear function is the cost or the price of monthly bill. So B of M equals 0.06 times M, the minutes used, plus that flat fee of $5.96. Okay, what are the independent and dependent variables? There's only 2 variables, and the 2 variables are minutes used and the monthly bill. Which one affects the other? Well, the minutes kind of drives how much that bill costs, right? So the minutes, so it says the independent variable is the minutes, yes. And the dependent variable is the monthly bill, because the monthly bill is dependent on how many minutes. So that's the dependent variable. So we have to highlight that as our answer. Now C, what is implied in the domain of this linear function? And they're going to tell us that 31 days is a month. Okay. Remember, this is supposed to be in the context of this problem. So what's the smallest amount of minutes that you can use on a phone? Well, that's going to be 0. So we're not going to have negative minutes. I'm going to have to include it with the brackets. It's inclusive. And then for some reason I thought there was another. Oh yeah, there was a problem. Okay, so now on some problems when you can't figure out how many total minutes or whatever, you just have to say 0 to infinity like the last problem. But this one, they're kind of giving us some clues here. How many minutes? How many? What's the max amount of minutes you could actually use on this phone with this plan? Well, quite a few, if you have teenagers. But anyways, how many minutes are an hour? 60. How many hours are in a day? 24. So 60 times 24 is how many minutes you can talk on the phone per day. And they're telling us, hey, this is a 31-month billing statement. So how many days in that month? 31. So if you multiply all 3 of those, that gives you the maximum amount of minutes you can possibly talk on this phone without sleeping or anything else, which is a little ridiculous. But anyways, that is the max. So it's 44,640. So 44,640. You can't do more than that because there aren't more than 44,640 minutes in 31 days. There's your interval. What is the monthly bill if 298 minutes are used? So the question is 298, that would be the M minutes. So 298. So if we were going to actually solve this, and I'm going to have to probably zoom in, I'm going to go to my formula, which was the bill. If I talk for 298 minutes, it's going to be equal to, remember the point, what was it, 6 cents per minutes of talking, which was 298, plus that flat fee that we had at the beginning, which is $5.96, right? Isn't that what we had up there? Yeah. Okay, so now all we have to do is solve it. So we're going to multiply first. And when I multiply that, I get $17.88. I need to add that to $5.96. I add those two together and I get $23.84. So the proper way to write this as a function, b of 298 equals, okay, and so we just found out that if you talk for 298 minutes, it's going to cost you $23.84. Once again, that $ units is already there, so we don't have to worry about that. How many minutes were used for long distance if the long distance phone bill? So now they're talking about the phone bill. I think I'm going to use another color here. They're talking about the phone bill. So the phone bill, in terms of a variable, would be B of M is actually the phone bill. $19.94. So I think space-wise, in order for me to squeeze all this in, I'm going to say we just got the phone bill being $19.94. And remember our formula was B of M, and that equals 0.06 M plus 596. So you can see that we actually know what B of M is. We know it is 1996. So we can replace that, substitute it in, 1994 rather, right? Let me double check my numbers, 1994, yeah. So now I have to do a solve. So I need to isolate. So I'm going to subtract 596 on both sides. When I subtract 596 on both sides, I get $13.98, and that equals 6/100 M. Divide by 6/100 on both sides. And of course, that reduces down to M. The number of minutes would be 233. So we found out, go back to 33. If the bill was 1994, how many minutes happen to be used for long distance? Happen to be 233. And you could also, if you wanted to see what that would look like, using function notation, that would just say B of 233 minutes produces a phone bill of $19.94. Okay. Once again, over here, 233 minutes, the units is already written in, so we don't have to worry about that. And now we're back to, can you take that linear model and figure out which graph does that go with? Okay, I got a mosquito bite on my arm, my wrist, and I just am feel like a dog scratching away here. But anyways, let's see here. What was the equation? Here it is right here. Okay, so I've got my equation right here, and we're trying to see which graph do we think that goes with. So I think I'm going to use green just because I was being consistent with that. That means my y-intercept equals $5.96. Now with a graph, $5.96, you might as well just call that $6, right? Because it's real hard to show, you know, 0.04 hundredths on a graph. But it should be very close to 6, right? That is my y-intercept. So when I look at these problems, well, what's the intervals? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like these are being counted by 2s, right? Let's see, 2, 4, so 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. Yeah, so they're going by 2s. So this is 6 right here. And so is that very close to $5.96? I would say yes, that is a good candidate. So I can't really eliminate that one yet. And this is also 2, 4, 6. That's also 6. That's very close to the y-intercept of $5.96. 2, 4, 6. That's also $6. So that's close. Excuse me. 2, 4, 6, 8, 10, 12. That is, right, that's close to 12. That is definitely not going to be our graph, because our graph has to be crossing at something close to $6. Now the other thing to notice, when we look at our formula, remember our formula, let's write it down again. B of m equals 0.06 m plus $5.96. This slope right here, the slope is positive, right? And this slope is negative, so that is not possible. Okay, so now we're down to 2 possibilities. Now we can try to figure out the slope here, but one thing about slopes that really can get crazy is that look at the scale down here. This is going from 0 to 300, and this is going from 0 to 20. And so, you know, it's hard to step up 3 and right 2 or whatever it is when the scales are different. It really actually very hard to adjust for that. So really probably the better way to do this is to realize we actually have some good points here. Remember back here at, let's see, yeah, right here. How about D? So let me go to some color here so it's easier to see what I'm talking about. If I go to D, D says, now this is we can write this as an ordered pair, right? This is saying B of 298 gave me, there it is right there, gave me $23.84. This is an ordered pair, right? I need a darker color, I think. This is an ordered pair, which would say, and I need a thicker pencil. Going crazy with this thing today. So this is saying when M is 298, then the cost, or so let's just like x's, let's call it like x's and y's. X is 298, then y would be 2384. But in this case, it's minutes and then cost of the bill. So since we're you know doing an estimate, 298 is very close to what? 300. $23.84 is very close to $24. So I think 300, 24. If a line is really close to that, then I'm pretty confident that the graph is correct. So I'm going to use these two numbers, 300, 24. So let's zoom in. Let's look at this one first of all. 300 is right here. This goes by 2s, doesn't it? So 20, 22, 24. So if I were to come across here, this is kind of a pain, and come up here, that is definitely far, far away from the line, right? You can see the rest of that line doing something like that, right? Right, that's definitely, oh, looks, man, that's good. I'm good there. Anyways, that's definitely far away from the point. But let's take a look at the other one. And let's remember it's really close. It's really 298, 2384, but it's so hard to graph that small of a point. So I'm just going to go close, very close to 300, 24. So once again, I go to 300, and remember 20, 22, 24. So it's somewhere around there, and somewhere around there. And does that look reasonable? And I try to snap the rest of this line. And yeah, that looks very reasonable. So this is our answer. So you can kind of do this by process of elimination. You probably could almost realize that that slope is climbing way too fast. But, you know, that gives you a very tangible way of doing that. Let's take a look at the last problem. This last problem is going to kind of challenge us to think a little more again in a different way. It says, over what range of minutes can you talk each month if you don't want to spend more than $21.14? You don't want to spend more than that. Okay. So here's, I think, the best way I can try to show this, and that is that, remember our statement. Let me start again here. Remember our linear function, b of m, and that equals 6/100 times m plus 596. So, as long as I know how many minutes the person's talking, this gives me my monthly bill, right? That actually produces my monthly bill. As long as I know how many minutes talking, I put the minutes in there and then I get my bill price. Well, when I read this, it says, over what range of minutes, so I'm going to have to solve for m, can we talk each month if we don't want to spend more than this? We don't want to spend more. So we want this to be less. We want this to be less than 21.14. Now it says we don't want to spend more than that, so it means we can spend that amount still. We just don't want to spend more than that. Now notice I have my less than symbol. So if I were to kind of try to speak this more in English than in math, I would say, okay, I want my monthly bill to be less than or equal to $21.14. That sounded pretty mathematical, I think. But anyways, I was trying to, instead of talk about this equation, I was trying to say my monthly bill instead of all this stuff on the left. But if you can set that up, then the rest of it's not too bad. All we have to do is solve. And so now all we have to do is, remember, subtract $5.90 on both sides. Subtract $5.96 on both sides. And now we have, let me just get rid of this so it doesn't feel confusing. Don't really need all that now. So now what do we have? Well, this, oh no, don't do that. This whole piece right here is opposite with this piece, so then we end up getting 0 there. We're left with 0.06 m is less than or equal to, and when I say 21.14 minus 596, I get $15.18. Oh, one more step and I'm there. Divide by 0.06 on both sides. 0.06, 0.06. Try to clean that up a little bit. Reduce, and I've got m is less than or equal to 253. So they want this in a range. Type your answer in interval notation. So they want to know what's the range of talking minutes that you're allowed to. So what's the minimum amount of minutes you can talk on the phone and still get a bill lower than 21.14? Well, you can talk for 0 minutes, and then it's just going to be the flat fee of $5.96. That's definitely below. Okay. You can talk all the way up to 253 minutes, which that's what we got here, right? 253 minutes. In fact, you could even talk 253 minutes, because if you talk 253 minutes, then it's 21.14, and you didn't spend more than 21.14. So that's the range they're talking about. That is the trickiest G question at the very end, but that means we're done, and that's good. I don't think there are any other questions, so we're good there. All right, well, I hope that helped out. You have a great day, and you take care. Bye.